everyone, and welcome to Education with Eleanor. Today we are going to induce a current with a magnet, so let's get started today. So today we are doing an experiment. It's actually out of the Jacaranda Physics 2 textbook, so it's for Unit 3 Physics in the Victorian curriculum in Australia. So it's Investigation 7.1, Inducing a Current. The equipment you need is a air core solenoid, looks like this, with 2 terminals. You will also need a bar magnet. The bar magnet looks like this, and a sensitive galvanometer. Now the galvanometer we have looks like this. It'd be good if we had a more sensitive one, but this is the one I'm using today. And I'm going to show you how we connect it up. The galvanometer we're going to use to observe the current flowing through the galvanometer when the magnet is moved in and out of the solenoid. So first of all, let's connect everything up. So here, these alligator clip wires connected into the end here. So can you see the metal on the end here? You want to make sure the alligator clips are actually connected and touching the end there. And I'll zoom out a bit. Oops. And we want it to connect to one of the terminals here. So in the background we've got another teacher teaching biology, so I apologise if you can hear that in the background. We want to connect to the other terminal, so there's the other alligator clip connecting there through to the other side. So it looks like we're connecting into there. Okay, now I'm going to take a step back. So literally I'm going to slide this in and out, and you will see this move. Now let's see if I can. I'm just going to see if I need to calibrate this so that this gauge is in the middle. I don't think I can. If I look at the back, no, there's no dial that I can move there. Just going to double check. No, I'm not going to move anything at the moment because I don't want to break it. No, nothing in the back. I'm not going to move anything. Doesn't really matter at the moment because we are going to see the needle move as I move this in and out of the solenoid. I'm going to move the solenoid to the side just so we can see what's going on. So here we go. Can you see the needle move? So as I move the magnet in and out of the solenoid, it induces a current. There is also an EMF, an electromotive force, or a voltage induced as well. So as I move the magnet in and out of the solenoid, we get a current induced. And we can tell that because the needle is moving in the galvanometer. Now, the galvanometer is measuring microamps. Amps are the units of current, or amperes. The second part of this question is what happens to the magnet if it's held stationary inside the solenoid and why? So the first thing we'll do is, I'm going to take a step back. Oops. First of all, we were moving the magnet in and out. So when you do move the magnet, you can see that the needle is moving, so a current is being induced. Now I'm going to place the magnet in the solenoid, but I'm not going to move it. Now you can see that the needle is not moving. When I'm going to move the needle now, move the magnet, watch the needle. You can see that the needle moves. Now I'm going to place the magnet back in, but then not move it. You can see that there's no movement in the needle, so there's no current induced when there's no movement. Okay. Alright, so in terms of we need to figure out why. So when we do the experiment in class, we're going to discuss why when the magnet is not moving, or when it's stationary, why is there no current? So what we need to remember is to induce a current. So what we're doing right now, when I move the magnet, okay, it's when there is a movement of the magnet that we induce a current. See the needle moving? The needle only moves, or an indication, see, a change in the amperes or a measurement of current is being read when I move the magnet. And it's because we're getting a change in magnetic flux. What does that mean? Okay, so it means that the amount of magnetic field or a change in the magnetic flux is passing through an area. So the amount of magnetic field passing through an area is changing because we're actually moving the magnet. And because that's moving, the amount of magnetic field is moving through the coil, it's inducing a current. But when the magnet is stationary, the amount of magnetic field passing through an area or the magnetic flux is not changing. Because that's not changing, we are not inducing a current. And that's what's really important to understand when you're trying to induce current. You have to have a change in magnetic flux or a change in magnetic field passing through an area. So, thank you very much for watching, and please click the like button and subscribe. Also click the little bell button so you get notified for any new videos that I load up. Thanks and bye. See you next time.